So today I am going to explain the art tester. Now, why do you need the art tester? Art tester actually measure the art resistance. And why do we need to measure the art resistance? Because our earthing, we pass it to the ground, and if the resistance of that ground or the earth is high, then the fault current will not pass through the earthing. That's why we need to measure the earth resistance, and that resistance should be very low for earthing. And here today I am going to explain the construction and the principle of an earth tester. So this is the complete diagram of an earth tester. Now here we can see the DC generator is there, which is called hand driven DC generator. Actually the power is generated by driving this armature with the help of our hand or with our hand. So that DC is generated. Then actually we use here current reversal. Now first of all, let me tell you what are the main components of the earth tester. Earth tester, it should have a DC generator, current reversal, rectifier, and the current coil and pressure coil, and the electrodes. So here two types of electrodes we have. One is this earth electrode, another these are called actually the auxiliary electrodes. Now what actually this current reversal do? The generated current is in the form of DC, and we have to pass the current in the form of AC through the ground. Why? Because if we pass the DC current through the ground, that will create electrolytic effect. So that's why we should pass AC current through the ground. That is the reason here the current reversal is used. So for simplification or for simplicity, let me tell you this: the bigger side represents the DC and the smaller side represents the AC. Now what it do when the DC, you can see here the DC is connected here and it is converted into AC. Now this AC is passed through this line. Next come to the point here, the rectifier. Why this rectifier is used? Because here we can see the PMMC type of instruments are used for the measuring purpose in the earth tester. So here this represents the pressure coil and this represents the current coil, and this pressure coil will be actually connected in parallel with the ground, and this current coil will be connected in series. Now now we can see here the DC currents are used for this PMMC type of instrument because PMMC works on DC. That's why again this power whatever AC we have, this is converted into uh, whatever AC we have, that is converted into DC with the help of a rectifier. So and then it we give it to the pressure coil of the PMMC. Now here we can see like electrodes are there. Actually it's having four terminals, and these two terminals C1 P1 are shorted and C2 P2 are open. They are connected with the auxiliary electrodes, and this terminal is the common terminal is connected with the earth electrode. So here this is the terminal or the electrode which will be connected to the earthing point where our home earthing is connected, or where we want to measure the earth resistance. Now again we can notice here this current coil and pressure coils are placed 90-degree apart from each other. So this is the construction of this earth tester. Now I will be going to explain the working of this earth tester, how this earth tester works. When we rotate the armature, the DC current will be generated, and this DC current is converted into AC with the help of current reversal, and this is going through the ground and it completes the circuit like this. So as I said, these are the AC terminals. It completes the circuit like this, and these are the DC terminals. So the same actually, the same current, uh, the DC current will pass through the current coil and completes the path like this, which will give us the measurement of current which is going through the earth. Now this current again have to be converted into DC to pass it through the pressure coil. Now we can see here the pressure coil, this AC current again is converted into DC with the help of this rectifier, and this is connected like this. It is connected to ground, and the this pressure coil is actually placed across these two poles N and S, and this side represents the output which is now converted, which is DC. So this is connected across the rectifier as well as across the ground with the help of the rectifier. Now this pressure will give us the measured voltage, and we will have the, with the help of the current coil, we will have the current which is passing through the ground, and so we can measure the resistance. As we know that the resistance can be represented the ratio of the voltage and current, so we can measure it. This actually these electrodes are placed 12.5 and 12.5 meter distance from each other, for example, and this current, the electrode which is connected to the current coil, that is placed far away from this earth electrode, and this is placed in between this two electrodes. This is the electrode which is connected at the potential terminal or a pressure terminal. So this way we can measure the resistance. Now which resistance we are getting here? Actually during experiments we have seen the line which was connected with the building to the earthing point, that was removed because we don't want to measure that resistance, we want to measure the earth resistance. So we have removed it and we have connected the earth electrode to the point where earthing is, earthing point. So at that point, and other two electrodes are placed far away from these electrodes in the same line. So here actually a deflector will be connected. When we drive the generator, this deflector will deflect and will give you the resistance. So during measurement, I think you have seen the resistance of when this point was connected to the earthing point, that time the resistance was very less, which is the desirable one, because the earthing resistance should be less, otherwise faulty current will not pass through the ground. And again we have noticed another thing during experiment. When we place this electrode somewhere like any other places, that time that point is not connected properly, that's why the resistance was showing more, means the earthing, that point earthing is not good. So this way we can measure the earthing resistance. and already you know why it should be low. It should be very less. If it is showing some other value like more than 10, then we cannot connect the earthing point to this ground. And we have taken the three sets of readings. We can change the position of these two electrodes in the same line, in the same distance, with different angle to get the three sets of reading. If we take the average, we can get the what is the earthing resistance of that.